All right, our last topic for functions is called graphs and functions. So write the title down, and then we have example 1. So a shoe store is having a sale, and the first pair of shoes sells for 40. The second pair sells for half price, or 20. The next pair sells for half of that, and so on. So make a table showing the cost of 1 to 5 pairs of shoes. So write down this table, and we're going to fill it in. All right, so let's see. If you buy 1 pair of shoes, the cost will be $40, is what it says. Then it says the second pair sells for half price, or $20. So if you buy 2 pairs of shoes, then it would be $40 plus half price, which is $20. So you'd pay $60 for 2 pairs of shoes. If you buy 3 pairs of shoes, it says the next pair sells for half of that. So every new pair of shoes is half of the previous one. So you'd pay 40 for the first one, 20 for the second one, and then you would pay 10 for the third one. If you add that up, you'll get $70. If you buy 4 pairs of shoes, the same pattern continues. So it'd be 40 plus 20 plus half of that, which is 10, plus half of that, which is 5. So you'd pay $75 for 4 shoes. So you can see the more shoes you buy, the better deal you get. So if you buy 5 pairs of shoes, you'd end up with 40 for the first, then 20 for the second, 10, 5, and then what would you pay for the 5th pair? $2.50. So the total for that would be $77.50. So what does this mean? This means that the total cost, the total that you pay, depends on how many shoes you buy. So the number of pairs of shoes that you buy. And this is called an independent and dependent relationship. Okay, so let's see. So what is the independent variable? Independent variable means that so the independent variable is the variable that you have control over, the one that you can manipulate. You can decide how many pairs of shoes you want to buy, but you don't control the cost. The cost is set by the store. So the independent variable is going to be the number of pairs of shoes that you buy. So you want to write that down. Number of pairs of shoes. And that's going to be your x variable. So your x variable is going to be there on the left. Your dependent variable is the variable that depends on the independent variable. It depends on how many pairs of shoes you buy. So in this one, the dependent is the total cost, which is y. So the cost depends on the number of pairs. And you're going to need to be able to identify the independent and dependent variables in a problem situation. So the way we see this is we say that, and the way we use functions, is that the total cost, you want to write this down, so the total cost is a function of the number of pairs. So the cost is a function of the number of pairs of shoes that you buy. All right, so this is a table of values that we've taken and put together from a problem. And now we've identified the independent and the dependent variable. Now we're going to make some ordered pairs out of this information, and then we're actually going to graph it. So let's list the ordered pairs that come from this table. So your x values are each associated with a y value. So here I have this x is associated with that y. So I would write an ordered pair of 140, and then I'm going to list the others, 2 and 60. That's what I pay for 2 pairs of shoes. 3 is associated with $70 for 3 pairs of shoes. If I buy 4 pairs of shoes, it was $75. And if I buy 5 pairs of shoes, it's $77.5 or $77.50. So we're actually taking this information, we're making ordered pairs, which means now we can graph it to see what it looks like on a graph. So now you'll need to get some graph paper because we're going to sketch a graph of this situation. Now we always put the number of pairs, the independent variable always goes here. So this is going to be your x values, just like you would on a coordinate plane, independent, and then your dependent is going to be up here on the side. So that's going to be the cost. All right, now we're going to need to fill in some numbers on our graph. So we'll start here with, that's 0 shoes, 1. Actually, we're going to skip and make this 1, and make that 2, and make that 3, and make that 4, and we'll make that 5. So ignore that one. And then on the side, we're going to list our prices on the side. So we're going to put $20 here. That's 20. Hopefully you'll do a better job than I'm doing. And this would be 40. This would be 60. So we're skipping a line every time. That would be 80 right there. All right, now we're going to graph. Wherever we see 1, we're going to put a point there at 40. Now, if you buy 0 pairs of shoes, how much are you going to pay? So let's go ahead and put a point there. Because if you buy 0 shoes, you're going to pay $0. If you buy 1 shoe, you're going to pay $40. If you buy 2 shoes, you're going to pay $60. 3 shoes, we said 70. So that would be there. 4 shoes, we said 75. That would be there. And then 5 shoes, $77.50. So let's go ahead and connect all the dots. And you can see that it's not a straight line or anything, because as you're buying more pairs of shoes, you're actually paying less money. So this is what our graph of this particular situation is. All right, let's do some more of this type of work. All right, example 2, you want to write down the information in this particular problem. It says a balloon is being inflated with air. As more air is pumped into the balloon, the volume increases until it finally bursts. We want to sketch a graph that represents this situation. So let's see what the independent variable is and the dependent variable. So air is being pumped, so that's a variable. And as the air is pumped, the volume increases. So you have air, write that down, and you have volume. So which one is dependent on the other? The air is what you have control over, so that's going to be, the amount of air will be your independent, because you have control over the amount of air that you put into the balloon. The dependent is the volume. The volume depends on how much air you put in the balloon. So the volume is a function of the amount of air. So write all of that down. So the volume is the function of the amount of air. So let's graph it. So we always put the x value down here, and that's going to be your independent variable. So this is going to be the amount of air. So you need a coordinate plane. So cut one out or draw one. And then over on the side is going to be your volume. All right, so where would you start this particular graph? You're always going to start, not always, but on this one you're going to start at 0, 0. Because if the balloon doesn't have any air in it, it has no volume. So we'll start there. Now, as you put more air into it, let's say, we're not even going to number this, we're just going to kind of graph it. So if you put this amount of air into it, you could end up with a volume here. So the more air that you put into it, the higher the volume. So what's going to happen is you're going to end up with a graph that as you put more air and more air and more air into it, it's going to get bigger and bigger. And then what happens, it says that it finally bursts. Well, if it bursts, that means your graph will go like this. It could even, maybe even go over this way. But this would be a graph of a situation in which a balloon is filled with air and then finally bursts. Okay, so this is kind of vague a little, but hopefully you're beginning to see what functions are on a graph. This next example, example 3, is an example of taking a situation, a word problem, and matching it to a graph that represents the situation. So we're going to read this problem and look at these 3 graphs and see which of these could represent this problem. All right, so for a certain time, Lucy jogs up a hill at a steady speed. So she's jogging up the hill. Then she runs down the hill and goes faster, picks up her speed. So which graph below can represent this situation? Now, we need to note that her speed, it depends on time. So write that down. Speed depends on time. And notice that speed is going to be your y variable because it's dependent, and time is going to be your x variable. So if you look at all graphs, you see that the time is the x and speed is the y. All right, so if she jogs uphill, which one of these shows her going uphill first at a steady speed? So there's no hill, you're not going up, right? It's just that you're going at a steady speed. So this is all about speed. So you can see here, is this a steady speed? Yes. Is her speed increasing here? Yes, her speed is increasing. So this cannot be her graph. And this one shows her speed increasing as well. So then she runs down the hill and picks up her speed. So she's going downhill, but then she's going faster. This graph shows her going faster, even though she's going downhill. So you're not looking for this one because you go up and down. This is not about going up a hill and down a hill. We're not graphing that part. We're graphing the speed. So the answer is going to be this one. So it shows her going at a steady speed at first, and then she picks up her speed. All right, might be a little confusing. Let's go on to the next problem. All right, for example 4, you have 2 graphs. So I'm now going to show you these 2 graphs. You're going to look at the graph, at the data in the table, look at the table, and you're going to match the table to a graph, and then you complete the statement. You're going to look at the independent and the dependent variables. So copy this down, the height of a following object. So you have time at 0, it's at 200 feet, at 0.5, 196 feet, at 1 second, it's 184, 1.5, 164, 2, 136, 2.5 is 100, and 3 is 56. So what is happening in this particular table? The time is going up, right? So you have time is going up. And then the height, what's happening to the height every time? The height is going down. So time and then height. So what depends on what? We need to know, does time depend on height, or does the height depend on the time? Well, let's see if we can look at some graphs. All right, these are the graphs that we want to match it to. So that first situation, is it going to match with graph 1, graph 2, graph 3, or graph 4? So let's go look at our information again. All right, what's happening every time here? This is decreasing by 4. This is decreasing by 12. Then it's decreasing by 20. Then it's decreased, I have to subtract in my head, by 28. And then it's decreased by 36. So as time goes by, it's decreasing quicker, right? So let's look at the graphs. If we look at the one that's decreasing quicker, I believe that would be graph 2. So as time goes on, he's falling down. Okay, so this is time is along here, and this is height. The the height is going down. So graph for that one would be graph number 2, and I want you to draw the graph that we just said. This is graph 2, so draw that graph next to this particular problem so you see what it looks like. All right, and what depends on what? I think the height is the dependent variable because it's going to depend on the time, and the time would be the independent variable. Independent variable is x, dependent variable is y. All right, let's look at example 4b. Here we have the cost of first class postage stamps. So you want to fill in this table. And here is the year, 83, 85, 87. So the year is going up, and then the cost is going up. So you see the year is going up and the cost is up. It's up by 3 cents here, and stays the same actually there. So here it stays the same, and then it stays the same here. So all through this section it stays the same, and then it goes up by 4 cents, and then it stays the same again, and then it goes up by 3 cents. All right, using this information, we want to look at our particular example. So it's going up by 3 cents, then it stays the same, remains constant over several years, and then it goes up, and then it goes up again. So which one of these shows that? This one doesn't show it, and we've already used graph 2. Graph 2 is for A, and this could be it, graph 3, and then graph 4. Now graph 4 can't be it. I'm looking at it because it says that it goes up at first, and you can see this is remaining steady, and then it goes up. So it's kind of the opposite, because on this particular one it's going up but then remains the same, then goes up, same, up. So okay, nice. I've got a Facebook message there. Very cool. All right, let's see. So I think it's going to be B is going to be this one. So it remains the same here. Then remains the same here. Remains the same here. So it kind of goes up, goes up, goes up. All right, that one is very confusing. I don't really like this particular one very much. All right, but we can answer this information. What depends on what? We have two variables. We have the year and we have the cost. So I would say the cost depends on what year it is. So the cost depends on the year. So at least you can identify this would be the dependent variable, this would be the independent variable. Dependent is y, not x, and independent is x. Okay, sorry for any confusing, we'll just keep moving on. Alright, so to summarize at the end, you need to be able to identify a dependent variable, which is always your y, and your independent variable, which is your x. And remember that you have control over the independent variable. You can determine and manipulate it and make it bigger or smaller. You need to know that the y variable is always a function of the x variable. And then you need to be able to either sketch a graph, just a simple graph, a lot of times without numbers or anything, but making sure that you have the dependent variable on the y-axis and the independent on the x-axis. And then, so you need to be able to sketch a graph for a situation or be able to match it. So your job is to do the worksheet as best as you can. Now this one you may even want to print out because it is a lot of word problems and graphs. So if you can, you might want to print it out and then we can work on it that way. All right, thanks for watching.